this is Miss Hanley, and today our learning target is I can analyze a linear equation in slope-intercept form. So slope-intercept form is your y equals mx plus b, or if you're thinking about functions, it's f of x equals mx plus b. Your slope is represented by the letter m, and your y-intercept is represented by the letter b. The way I like to think of it is when we're graphing in slope-intercept form, b is where you begin, and m tells you how you move. If you remember those two simple things, graphing in slope-intercept form is very, very simple. So originally, if you were given a slope and a y-intercept, you can fill out your equation as y is equal to 1/2 x if 1/2 is our slope, and plus 3 because our y-intercept is a positive 3. If it were a negative 3, then it would be a minus 3 at the end of your equation. So this means that our graph is starting at the point 0, 3, and then it tells you how to move up 1 into the right 2. Since it's a positive slope, you're moving up because that's a positive direction, and to the right is also a positive direction. Remember that you can also go the opposite direction with your slope. If you normally go up 1 to the right 2, you could also go down 1 and to the left 2. So you can make both pieces the opposite, in that will give you the same line. So looking at the graph that we have below here, we have started our graph at the point 0, 3, and our slope is up 1. Oh goodness. Sorry about that. Start our graph at 0, 3, and we always start on the y-axis, and then your slope is up 1 to the right 2, up 1 to the right 2. Again, you could go down 1 and to the left 2, and you'll still be on the same line. Once you have 3 points, and it's best to have 3 points. If you can't get 3 points, you can only fit 2 on your graph, that's okay, but 3 is always better. And remember, we can't make a line with only 1 point. We don't know what direction to go in. So once you've done that, you're just connecting your dots and drawing a line. There are a few different situations for lines that we can have. For example, the line that we just graphed has both an x and a y in it, which means it is a slanted line. That's not always going to happen. We can also have those constant functions, and constant functions are just a horizontal line. When you have a constant function, you will only have a y in your equation. So it may say y is equal to 5, or y is equal to negative 2. That tells you your line is horizontal. Remember, horizontal lines have a slope of 0. So technically your equation is y equals 0x plus 5, but we don't have to write 0x because 0 times anything is always 0. The opposite of that is when you have a vertical line. If you have a vertical line, you will only have an x in your equation. So it may look like x is equal to 7. This is an undefined slope, remember, and actually not a function. So think about if you're given an equation with just an x or just a y, that should trigger something in your memory, and realize that you don't necessarily have to have a y-intercept and a slope there. You're just finding 1 point and making a vertical or horizontal line. Finally, there are 2 things that we must have in order to create the equation of a line from a graph. And if we're thinking slope-intercept form, those 2 things are going to be a slope and a y-intercept. Always, always need slope and a y-intercept. And if you can find those two things, you will be all set to fill in your equation. How do we find slope? Well, you're using rise over run if you have a graph, so you can make sort of a right angle. Let's say I have 2 points on this line, and I want to find the slope between them. Well, the slope will be the same between any 2 points on the line. You may have to reduce it, but it will be the same. So I make a right angle from one point to the next, and let's see. We have gone up. Oh, my line got a little crooked there. But we should have gone up 2 spaces and to the right 1 space. So your rise over run would be 2 over 1. And that's the number you could replace your slope with. We can also say that our y-intercept is where it crosses the x-axis, or excuse me, the y-axis. In this case, it's not an even point, so maybe our y-intercept is 1/2. And that's okay, but that will be our b value, or the value that goes at the end of our equation. We now want to take a look at analyzing a linear function in all different ways here. So we're looking at a function that's in y equals mx plus b. It's in slope-intercept form, and that is y equals 2x plus 3. Let me get my page to stop moving here. Oh gosh. Okay. We're back to where we started. So if you see an equation y equals 2x plus 3, I know that I'm given an equation in slope-intercept form because I have a number next to x times x and then a number added to the end. Well, which of those numbers is your slope? That is always the one that is in front of your x value. It's also represented by m. So in this case, our slope is 2, and that's represented with the m. Our y-intercept is what is added to the end. So in this case, it's a 3, which is your b value. We've worked a lot on writing these equations in different forms. So if you take y equals 2x plus 3, and we want to change it into standard form, which is ax plus by is equal to c. Our first step is to move the ax to the left-hand side. So if it's a positive 2x, we're subtracting. So we end up with negative 2x plus y is equal to 3. Finally, we have to check our rules, and we're not allowed to have a negative a value. So in order to fix that, I want to multiply all the way through by a negative 1. The result is 2x minus y is equal to a negative 3. Now let's go to the other side and talk about the variables. From the beginning of the year, we talked about independent and dependent variables, which can stand alone and which depends on something else. In this case, your x is standing alone. Those are what you choose to substitute in, and your y is the dependent variable. So now that we've looked at all of those, let's take a second and fill in a table of values. Usually, if you're given 5 different points, and we're graphing a line, we can pick negative 2 to positive 2 as our x choices to substitute. Negative 2, negative 1, 0, 1, and 2. And remember, to find the y values, you're substituting all of those in. So for negative 2, we would have 2 times negative 2 plus 3. Well, 2 times negative 2 is negative 4, plus 3 is negative 1. Now we're going to repeat the process for all the values that we have. 2 times negative 1 this time is going to give me -2, plus 3 gives me +1. And I notice a +2 increase in my y values. Let's see if that pattern continues. Next, we want to substitute in 0. Well, 2 times 0 is 0, plus 3 is 3. Again, +2 increase. For those of us who have looked at arithmetic sequences, you'll notice that linear functions always create arithmetic sequences, and if you can find that common difference between your range, that will tell you how to complete the pattern. So if we're going up by 2's, our next number would be a 5 and then a 7. Why do we go up by 2's? Well, our slope is a 2, and that's how much we increase by each time. So now that we've got that down, let's go and graph it. The points that are in our table should be the same points on our line, but I'm going to use the graphing trick we just learned. So remember, B is where you begin, and M is how you move. Well, B is at +3, so I'm going to go on my y-axis up to +3. And my slope is 2, which is 2 over 1 if I create a fraction. So I can move up 2 to the right one, or down 2 and to the left one. You only really need 3 points to graph, but I'm showing you that all of those points that were in our table are actually on our line. Here's -2, -1, -1, 1, 0, 3, 1, 5, and 2, 7. Once you've gotten that, you can connect your dots and put arrows on both ends. Last couple things we want to talk about here are bringing us back to the function unit. So we talked about parent functions before. That's your most basic linear function. And the general equation was f of x equals mx plus b. We did talk about that. However, the parent function is when your line goes through 0, 0, the origin, and your slope is 1. So you result in an equation that is just f of x is equal to x. So when you have f of x equals to x, it goes through the origin, and its slope is 1 over 1, so up 1 over. We know it goes through the origin because there's no plus or minus on the end of that equation. Well, if you look at the equation that we were given, we have a +3 at the end. So if I see +3, I know that my function is not going to pass through the origin, it's going to pass through 3. The +3 is a vertical shift up 3 spaces. From the origin. So you took that parent function and you shifted it up 3 spaces. We also want to know if it's going to be an increasing or a decreasing line. Well, if we look at the one that we graphed, it was increasing. I could find that out without even looking at my graph though, because 2 is a positive slope. And we also know that because 2 is a larger number, we should have a steeper slope than the one of our parent function. Finally, we talk about domain and range. Domain, remember, is all of your x values, and range is all of your y's. If you have a line that keeps extending and extending, it's infinite. So it's going to stretch left and right infinitely, and it's going to stretch up and down infinitely. And when that happens, you end up using all of your x's and all of your y's. So for our domain and our range, we talk about it as all real numbers, or the set of all real numbers. We would eventually need every single x and every single y value.